As humanity forges ahead into the final frontier, we've witnessed remarkable milestones in space exploration. India has triumphantly reached the lunar South Pole, NASA is gearing up to probe the enigmatic surface of Venus, and Neptune's mysterious dark spots are under intense scrutiny. Amid these scientific breakthroughs, whispers of extraterrestrial life have grown louder, even within NASA's hallowed halls. However, the biggest revelation yet is about to shake our understanding of the cosmos. Evidence suggests that Neptune, once deemed inhospitable, might harbor signs of life. Imagine a world once deemed utterly inhospitable, now sparking intense speculation about the presence of extraterrestrial life. Neptune, the distant and mysterious ice giant, might hold the secrets we have long sought. Recent investigations have unveiled bizarre phenomena that defy previous understandings, hinting at the tantalizing possibility of life existing in its frigid, turbulent atmosphere. Stay with us as we take a deep dive into this amazing discovery that has the entire scientific community on edge, exploring its potential consequences and the tantalizing mysteries it unveils about our place in the universe. But before we continue, if you are fascinated by the incredible discoveries and spectacular wonders of the universe, be sure to subscribe to The Rocket to continue exploring the cosmos with us. We know there's life on Earth, but could there be life on Neptune? And if there is, what kind of life would it be? Wherever we find liquid water on Earth, we find life. Whether that water is deep underground, inside nuclear reactors, or within glaciers, life finds a way. It might just be tiny microbes, but it's life nonetheless. To find life on Neptune, the planet would need a source of energy that bacteria could use, along with a standing source of liquid water. Neptune's surface temperature is a frigid 55 Kelvin, so cold it would make your freezer feel like a sauna. But there might still be a way for liquid water to exist. As we venture deeper into Neptune's interior, temperatures and pressures increase. There could be a region on the planet where water stays liquid, possibly providing a home for life. This area would be hundreds of kilometers below the surface and beyond our current ability to study, but the possibility is there. Right now, scientists aren't sure if there's life on Neptune. The conditions on the planet seem very hostile. But with a recent stunning discovery, our perspective might slowly be changing. The idea of life on Neptune, once considered laughable, is now something scientists are seriously considering. Imagine that, a neighborhood where our nearest neighbor might be a microbe living hundreds of kilometers below Neptune's icy surface. It's a wild thought, but in the vast expanse of space, who knows what surprises await us? With this shocking new discovery, it might actually be possible. When Voyager 2 reached Neptune in 1989, just 12 years after embarking on its historic journey through the solar system, it made some incredible discoveries. It found 6 new moons orbiting the planet, captured the first images of Neptune's rings, and noted a particularly violent storm that took everyone by surprise. This storm, located in Neptune's southern hemisphere, featured swirling, counterclockwise winds reaching up to 1,500 miles an Mach, 2,414 km/h, the strongest winds ever recorded in our solar system. Astronomers named this massive storm the Great Dark Spot. However, by the time the Hubble Space Telescope checked in on Neptune 5 years later, the Great Dark Spot had vanished. This disappearance intrigued scientists, who were eager to understand why Neptune's winds were so extreme and how such a massive storm could simply dissipate. This discovery added a layer of mystery to Neptune, fueling scientists' curiosity about the planet and its potential to harbor life. Could such powerful forces somehow create an environment where life might exist, even in the deep, hidden layers of the planet? They were also perplexed by another issue. Voyager 2 revealed that Neptune is warmer than Uranus, despite being farther from the Sun. As physicist Brian Cox discussed in his BBC documentary, The Planets, the source of this extra heat remains a mystery. But does that mean we have a double puzzle on our hands? And can one mystery help to explain the other in some way? Before we dive into these intertwined enigmas, let's clarify what we mean by warmer. Neptune is a gas giant, which means we can't measure a globally average temperature at ground level, as we do on Earth. Instead, temperature measurements must be taken at various altitudes in Neptune's atmosphere. But which altitude do we choose for a meaningful comparison? "We can only measure temperatures in the outermost layers," said Michael Wong, a planetary scientist at the University of California, Berkeley, via email. When we do this, we find that Neptune isn't actually hotter than Uranus in absolute terms. They're essentially at the same temperature. However, since Neptune is farther from the Sun and receives less solar illumination, it shouldn't be as warm as Uranus. This similarity in temperature suggests something fascinating. Neptune is warmer relative to the amount of heat it absorbs from the Sun. Voyager's measurements show Neptune emits more than twice as much heat as it absorbs from the Sun, while Uranus does not. Anthony Del Genio of the NASA Goddard Institute for Space Studies, GIS, told All About Space. And this is where things become rather intriguing. Could this mysterious internal heat be linked to the potential for life on Neptune? If there's an internal heat source keeping Neptune warmer, it might also create pockets of liquid water deep within the planet, despite its freezing surface. Just as we see on Earth, where geothermal heat can sustain life in the deep ocean, Neptune's internal heat could potentially sustain life in its hidden, warmer layers. So, while Voyager 2's discovery of Neptune's unexpected warmth might seem like a separate puzzle from the search for life, the two mysteries could be connected. Understanding why Neptune emits so much heat might also bring us closer to finding out if this distant, icy world could harbor life in its depths. It's a thrilling thought that keeps scientists eager to learn more about this enigmatic planet. That's because Neptune is not unusual in this case. Jupiter and Saturn also emit almost twice as much heat as they absorb, but Uranus does not, Del Genio said. Uranus is the oddball. The progression of temperature as you go farther away from the Sun shows Jupiter to be the warmest of the gas giants, Saturn next, then Neptune. Uranus is the one that is out of place, Del Genio continued. Yet that unusual result is associated with the fact that Uranus does not have a significant internal heat source. Neptune finds a way to warm itself up to the level of Uranus, while Uranus remains chilled, relying solely on the Sun for its heat. But what exactly is an internal heat source? In simple terms, it's heat left over from the birth of the solar system when these planets were formed. This heat comes from the contraction of the primitive solar nebula, a process known as the Kelvin-Helmholtz contraction. The extra heat source on Neptune and Jupiter and Saturn is largely due to gravitational contraction, said Joshua Tollefson, also of the University of California, Berkeley. As the planet slowly gravitationally contracts, the material falling inward changes its potential energy into thermal energy, which is then released upwards out of the planet. However, Uranus is a mystery. There's no clear reason why Uranus lacks an internal heat source. Something must have stunted this process on Uranus, perhaps due to a collision in its early history that knocked the planet on its side, Tollefson suggested. The question becomes, why does Neptune have an internal heat source but Uranus does not? This difference in internal heat could have implications for the potential for life on these planets. Neptune's internal heat might create conditions where life could exist, perhaps deep within the planet. Meanwhile, Uranus, with its lack of internal warmth, seems less likely to host life. So, while we ponder the mysteries of Neptune's surprising warmth and potential for life, we're also left scratching our heads over Uranus. One planet heats itself from within, hinting at hidden depths where life could thrive, while the other remains mysteriously cold and quiet. There is a possibility that heat is not released from the interior at a steady rate, but instead comes in burps. We may just be seeing Uranus in a quiescent period, whereas Neptune has burped more recently, said Tollefson. The burps are convection, which may happen in discrete episodes separated by long time periods, but we may not know if it works this way for sure unless we see one of these convective episodes take place. It could also be an issue of Uranus being an old-timer and Neptune a younger pup. How much heat a planet radiates depends mostly on how old it is and how quickly or slowly it releases that heat, said Amy Simon, a NASA senior scientist for planetary atmosphere research at the NASA Goddard Space Flight Center. An older planet would be colder. How quickly they release heat depends on the interior structure and composition, cloud layers, convection, and so on, and that can be rather complicated. On the gas giants, there may be significant amounts of helium rain, changing the amount of heat released. For Uranus and Neptune, it is possible that they are different ages, or more likely, the event that turned Uranus onto its side may have jumbled its interior structure and/or released heat faster, said Simon. So, what of those fierce winds on Neptune? They may have something to do with temperature differences. The immense internal heat of Neptune could drive these powerful storms, like the Great Dark Spot observed by Voyager 2. This heat, rising from within, might create strong convection currents that lead to the extreme weather patterns we see. Imagine Neptune's atmosphere as a massive pot of boiling water. The heat from below causes the gases to rise, creating turbulence and storms. If these burps of heat release occur periodically, they could lead to temporary but intense increases in wind speed and storm activity. In contrast, Uranus, with its lack of significant internal heat, doesn't experience the same level of atmospheric turmoil. Its winds, while still present, are not as extreme. The planet's calmness might be a sign that it's in a quiet phase, or it could simply be an older, more settled world where the internal dynamism has largely played out. As we continue to study these distant giants, we gain more insights into their complex behaviors. Neptune's internal heat and dynamic atmosphere hint at the possibility of hidden processes that could potentially support life deep within its mysterious layers. Meanwhile, Uranus remains an enigma, a planet that defies easy explanations and invites us to keep searching for answers. In the end, the more we learn about these icy giants, the more we realize how much there is still to discover. Whether it's understanding the internal heat sources or unraveling the mysteries of their stormy atmospheres, each piece of the puzzle brings us closer to a fuller picture of our solar system's outer realms. We've speculated for a long time that the coldness of Neptune and Uranus might lead to near frictionless conditions and so allow for faster winds, said Heidi Hammel, a planetary astronomer who has extensively studied both planets and was part of the team imaging Neptune from Voyager 2. By this, she means there are no mountains, hills, or other landforms on Neptune to slow down the winds. But is there any relationship between the storms and the internal heat source? Probably, said Hammel, but there is also some delicate balance between the internal heat and the incoming sunlight. Quantifying these effects is challenging due to the long time scales involved. 1 year on Neptune is 165 Earth years, so we have not had a chance to study the planet with modern tools for very much of its seasonal cycle, Hammel explained. You need a lot of patience and trust in past and future generations of planetary scientists to study the atmospheres of outer planets. The theory was that more solar energy would lead to more wind energy. However, as Anthony Del Genio pointed out, on Earth, only a tiny fraction of solar energy is converted into wind energy. Earth is a very inefficient heat engine, and it doesn't give you much bang for the buck, Del Genio said. One reason for this inefficiency is Earth's solid surface, which dissipates wind energy through friction. The gas giants, lacking solid surfaces, don't experience this friction, allowing for much stronger winds. On Neptune, the internal heat source contributes significantly to these powerful winds. This internal heat, which arises from gravitational contraction and the Kelvin-Helmholtz mechanism, might be released in bursts, creating conditions for extreme storms. The balance between this internal heat and the minimal incoming sunlight creates a unique environment where winds can reach extraordinary speeds without the interference of surface features. In summary, the mysteries of Neptune's fierce winds and internal heat are intertwined. The planet's near-frictionless conditions, combined with its internal heat source, create an environment where winds can rage at incredible speeds. As we continue to study Neptune with advanced tools and over longer periods, we may uncover more about these dynamic processes and their implications for the potential of life deep within this distant, icy giant. So, as we ponder the remarkable forces shaping Neptune's tumultuous atmosphere and the enigmatic source of its internal heat, we're reminded of the vast mysteries that still elude our grasp in the cosmos. As we peer into the depths of space with ever-advancing technology and growing curiosity, one question lingers. What secrets lie hidden within Neptune's icy depths? And could they hold the key to unlocking the possibility of life beyond Earth?